when every millisecond matters. Caching isn't a luxury, it's survival. Let's explore the strategies that power the fastest systems on the planet. Least recently used, or LRU, is the most classic cache algorithm. It removes the item that hasn't been accessed in the longest time. Ideal when recent usage implies future need. Used by Redis OS memory caches and CPU L1/L2 systems. Simple, effective, and a great default for general-purpose workloads. Least frequently used focuses on access count. Not recency, it evicts items used the fewest number of times. Works best when some data is accessed heavily over time, like configuration keys or hot product listings. But it needs counters, and those counters must be decayed or cleaned periodically to avoid memory bloat. FIFO is dead simple, the oldest entry gets evicted first. But here's the problem, what if that old entry is still being accessed? FIFO doesn't care, that makes it risky for most production systems, though it's sometimes used for streaming buffers or test environments. No recency, no frequency, just pure randomness. Random replacement evicts a randomly selected item. Surprisingly effective in ultra-low resource systems where tracking access patterns isn't feasible. It's not smart, but it's fast and light. Arc is where things get clever. It combines the strengths of LRU and LFU, adapting based on actual usage patterns. If your workload shifts between recency-heavy and frequency-heavy, Arc adjusts automatically, used in enterprise storage systems and high-performance caching layers. 2Q keeps two lists, one for recently accessed items, and one for frequently accessed ones. It helps solve the single-use pollution problem of LRU. Great for databases and disk caches where reading something once shouldn't dominate memory. Not all cache items are equal. Some are huge. GDSF takes both size and frequency into account. It's used in web proxies and media delivery systems where memory footprint matters. For example, it might evict a huge image accessed 3 times to make room for 3 smaller, high-frequency ones. Why serve content from one place when you can serve it from everywhere? CDNs cache static content closer to users' images, videos, styler sheets, reducing latency and offloading your origin server. Great for global reach and massive scale. Reverse proxies like Varnish, Nginx, or Traffic can sit between your client and backend, caching entire HTML pages or API responses. Think of them as interceptors that answer before your backend gets involved. Perfect for high-read APIs or semi-static content. This is the fastest cache there is, right inside your app's memory. Useful for small data like session tokens, flags, or recent activity, but be careful, this cache is not shared across instances, and it disappears when your app restarts. When one server isn't enough, go distributed. Redis and Memcached allow shared caching across multiple services. This is your go-to for session stores, rate limiting, and database query caching at scale. Fast, scalable, and production grade. In write-through caching, every update is written to both the cache and the database immediately. It keeps things consistent, but can be slightly slower on writes. Great for systems that require high read reliability and no stale data, like banking or real-time dashboards. Here, writes go only to the cache first. The database update happens later. Asynchronously, this boosts performance, but risks data loss if the cache crashes before syncing. Use it when throughput is more important than immediate durability, like in logging, analytics, or gaming systems. You've heard it before, there are only 2 hard things in computer science: cache invalidation and naming things. And it's true, if your cache holds outdated data, It can lead to bugs, data leaks, and user confusion. Use TTLs, versioning e-tags, and purging APIs wisely. Remember, stale cache is worse than no cache. Caching isn't just a backend optimization, it's an architectural strategy. And now, you've seen the 15 most important caching algorithms and techniques that power everything from mobile apps to high-frequency trading systems. Want your app to scale smoothly, perform consistently, and save money along the way? Master caching. You've just learned 15 powerful caching strategies that keep systems blazing fast. Caching isn't a hack, it's architecture. Master it and your apps will thank you.